Hi, my name is Jenny Agnew, Business Sustainability Manager at Sedgman. My colleague, who is co-presenting, is Bernadette Curry, our Metals Business Development Manager for Australia East. Just a quick introduction to Sedgman to provide some context. We design, construct and operate minerals processing plants and associated infrastructure across various commodities and regions and have recently celebrated our 40-year anniversary. Whilst it's critical to have specialist environmental companies and solutions, in our industry it's equally important for those involved in the whole mining value chain to work collaboratively to reduce land and ecosystem impacts. Both reducing land impacted by mining and responsible management of water are key to maintaining healthy ecosystems. From a processing perspective, we are focused on reducing land impact through alternate mine and processing approaches, reducing land impacted from tailings, including reprocessing for economic rehabilitation, reutilisation of mine impacted land for renewable power generation, reducing net water and energy consumption through alternate processing routes, including those that eliminate the need for intensive crushing and grinding of ore and favour targeted extraction from feed sources, reducing water use through tailings management solutions, managing the impacts of acid mine drainage, and ensuring the stability of dams to avoid failures impacting ecosystems, which could include offering alternatives to conventional containment, eliminating the risk on closure liability.
Reprocessing of mine tailings can have great outcomes for reducing landscape and ecosystem impacts. The final products have a lesser footprint as no additional land has been disturbed by mining these in situ deposits. With careful closure planning and consideration of available storage options, the reprocessed tails can be deposited into open pits, underground voids, and or shafts for secure forever containment. The economic value generated from reprocessing tailings provides the cash flow to offset the optimal rehabilitation and to some extent decontamination of ongoing tailings liabilities. A great example of this is Century Zinc Mine, a new Century Resources owned project in far northwest Queensland, on which Sedgman provided engineering, construction, and modifications to the existing facilities and oversaw an initial operations management period to enable successful reprocessing of historic zinc tails. The project allowed much of the rehabilitation to be achieved through new cash flow generating activities, and after reprocessing, the material is being relocated into the existing open pit and eliminates the need for capping the tailings dam surface. Every mined resource operation has a historical yield or metallurgical performance over the plant lifetime, and by reprocessing to retrieve that residual economic value, the overall recovery of valuable elements is improved, and so is the ratio of the impact to the environment per ton of product produced. Furthermore, by recovering byproducts not previously targeted in primary processing, particularly critical battery minerals, for instance, cobalt associated with copper or nickel minerals, an asset can offset the need to mine elsewhere to meet growing demand and save those sources for future generations. When developing a project, there are approaches such as ore sorting or feed material upgrading that can reduce the volume of material crushed and processed through the plant, lowering the final tailings volume. Although this practice may increase the mined and moved material for the same amount of saleable product, there can be a significant drop in processing burden. Sedgman can support the modeling of options at different grade selections and to optimize the MPV, as well as other environmental drivers such as tails volumes, greenhouse gas emissions, and energy use. Sedgman have delivered tailings dewatering installations across multiple commodities and regions. And whilst capitally intensive, filtration and dry stacking allow a small footprint due to the significant reduction in contained volumes and greater water recovery and reuse, which is an operational cost savings and key driver in areas of high water stress. Two recent examples of Sedgman EPC contracts where dry tailing disposal technology led to easier and less costly rehabilitation and a reduced liability by eliminating the risk of dam failure were a copper processing facility in Nevada and a red mud filtration and stacking facility in Western Australia. Alternate and future mining approaches to change the landscape include precision mining technologies such as surgical drilling. And one example on the processing side is in situ leach, which allows the co-location of mining, agriculture, and other land uses, such as the installations of renewables. And in select cases, dissolving the target minerals into solution can take place in ground by pumping weak acid or other lixiviants into the ore body through injection wells and collecting the solution flows containing the valuables for processing without mining the ore. Sedgman has hydromet experts to develop those sheets and mass balances and evaluate the project economics to convert that enriched solution into saleable metal products.
Reutilising already disturbed land, such as mined areas or tailings facilities, is a good option instead of placing solar farms on undisturbed or arable land. For a sense of scale, a 125 megawatt off-grid solar renewables farm can cover 245 hectares. Sedgman can support assessment and execution of on-mine solar installations through our CIMIC Group sister companies, Pacific Partnerships Energy and UGL. Some underground mines, when closed, can use height differentials for energy storage.